Okay, this is our first lesson back from spring break, and we're going to take a little bit of time and review simplifying trig expressions. Let's begin. First of all, one thing we want to keep in mind is that trig expressions are basically algebraic expressions and use the same kinds of rules. So let's begin with just a real quick review. If we've got x plus x, we know from algebra that x plus x is the same thing as 1x plus 1x, which is 2x. And we can do the same kind of thing with sine x plus sine x. We could say this is 1 sine x plus 1 sine x, just like those ones. And when we combine those together, we're going to get 2 sine x. Because we've done these before, I want you to pause the video and for a moment try the next 3 here and the next 3 there. Okay, let's take a look at the next ones and see what these end up turning out to be. Here we've got x minus x, or 1x minus 1x, which is 0x, or just 0. Here we got x times x, which is x squared. Keep in mind when we multiply and the bases are the same, we add the exponents. And for the final one, x divided by x, we can go ahead and basically cancel or simplify here and make them into ones. And 1 divided by 1 is 1. Now there is one exception to this one. X does not equal the number 0 because 0 divided by 0 cannot be determined. Let's go ahead and see how these problems mirror or match up with these 3 problems on the left. Here we get sine x minus sine x, or 1 sine x minus 1 sine x, which is 0 sine x, or 0. Sine x times sine x, we're going to write that as sine x. But when the whole quantity is squared, we put the squared here, not after the x. The final one, sine x over sine x, is like this problem. We can cancel these. They become 1s. 1 over 1 is just 1. Okay, enough of that review. Let's take a look at, very briefly, some strategies that we covered before spring break to simplify trig expressions. We're going to end up using these strategies quite a bit. The very first thing is to change everything into what? Sines and cosines. So change into sines and cosines. A second strategy, use our trigonometric identities. Remember our purple formula sheet. So we're going to use the identities. And sometimes we may need to rearrange those identities. A third strategy, sometimes we may need to distribute to simplify. Other times, we may see a situation where we have a binomial multiplied by another binomial, and we can say that the FOIL process is helpful there, first, outer, inner, last. And a fifth strategy that we can often use is factor. Now, there are other strategies as well, but these are the 5 that we went through over break. Let's go ahead and look at several examples. We'll start with these here. Number 1. So which strategy should we use? Well, basically, you're going to want to use your judgment and try to figure out which strategy fits in that particular problem. When we look at this problem, we have cosine times secant. And our go-to strategy that we've used more than any other is change into sines and cosines. Let's give that a try. And so here, this is already a cosine, so we keep it the same. However, secant, we know we can write as 1 over cosine. Next step, well, we have a fraction here, what looks like a fraction. And we know fractions work well together. So let's go ahead and make this into a fraction as well. Put it over 1. And because this is multiplication, we can use our rules for multiplying fractions. Basically, we know when we multiply fractions, we can simplify or cancel out the cosines and they become 1s. So the final answer is 1. What I want you to do is I want you to go ahead and try problem number 2 on the right of this one. So pause the video, try it, then we'll go through that. Okay, Let's take a look at problem number 2. Problem number 2, similar to number 1. Here we'll write everything in terms of sines and cosines again. And so here we have sine x over 1. Secant is going to be 1 over cosine x. And cotangent is going to be cosine x over sine x. And all those, of course, come from your purple formula sheet. Next step, what did we do next in the previous problem? Well, because we have fractions right here, let's use our rules of fractions. We know we can cancel the cosines, also cancel the sines. Final answer, 1 again. Is the answer always 1? Obviously not. Let's go ahead and take a look at problem number 3 below. 3 is a little bit tougher. Try number 3 on your own first. Okay, let's take a look at problem number 3. Cosecant minus sine. What do we do? Well, let's go ahead and change everything into sines and cosines. This will be 1 over sine minus sine. Because this is a fraction, let's go ahead and make this also into a fraction. We know fractions work well together. So we'll put this over 1. Now, whenever we are subtracting fractions, the first thing that we need to do is make sure to combine these, we have a common denominator. That's true only when you add or subtract fractions. Here we have sine x, so let's make this into sine by multiplying both the numerator and denominator by sine x. Let's go ahead and see what we get now. This will be 1 over sine. Sine times sine gives us sine squared in the numerator over sine. Now we're ready to combine our fractions together. And so we have 1 minus sine squared in the numerator. Denominator stays the same. But when we look at our formula sheet, 1 minus sine squared is basically just cosine squared. So the numerator becomes cosine squared. Now the next part. Let's go ahead and separate this. If the squared was not here, it would be cosine over sine, which is cotangent. But the squared is here. So let's go ahead and write the numerator as cosine times cosine. Let's write the denominator as sine times 1. Well, cosine over sine is going to be cotangent. Cosine over 1 is going to be cosine. And that's it. That's as simple as it gets. All right. I want you to try the final problem, number 4, on your own. Again, you want to choose one of these strategies right here, and then we'll go through problem number 4. So pause it. Okay, ready for problem number 4. Let's go ahead and work that one through. First of all, we do in number 4 have a binomial 2 terms times another binomial 2 terms. And so we could use FOIL here. Let's go ahead and do that. When we multiply this, secant times secant gives us secant squared. Secant times -1 gives us minus secant. 1 times secant gives us secant. 1 times -1 gives -1. These terms drop out because they are opposites, and so we're left with secant squared x minus 1. Now, is there something else that we can do? Well, let's think about an identity that involves both the number 1 and a secant squared. And the identity from our purple formula sheet looks like this. Tan squared plus 1 equals secant squared. Now, let's make the right side here exactly this. Well, we already have secant here, so we're set with that, but we need to get the -1 here. So let's do -1 here, and then we do -1 here. And we get that secant squared minus 1 is actually tan squared. So our final answer, because we have secant squared minus 1 here, and that matches exactly this, is tan squared. Hopefully, this helps with your homework assignment. Do your best, and I will see you shortly. Bye-bye.